So I'm going to continue with the second part. Let me share my screen. I have just a couple of exercises. The first one, we're going to extract the trajectory from PDF files. On the second one, I'm going to start to do some inspection on the pressure data from the measure while drilling log. You can see my screen. Can you all see my screen? All right. I'm going to assume that you can see it. The first thing is let me show you a bit of what's happening with the data. So the well trajectory, I didn't find any explicit file with the well trajectory, and I thought that this might be a good opportunity to actually do some exercise which involves getting into a PDF file and extracting PDF data. So the nearest information related to the well trajectory, it's the end of well report. It's quite a few information there, and if we go to the bottom of a report, there are multiple tables. Where are the tables?
I'm seeing Teams, not a PDF or a files screen.
What about now?
Yes, perfect.
Right, thank you. It's good. It's good when I hear someone speaking. Sometimes I don't know if people is listening or not, so it's great to have some feedback, at least on the matter of the format and what you can see and what you cannot see. But anyhow, so we have an end of well report, and somewhere in the end of well report, I believe in this particular case, we have these tables with the measured depth, inclination, azimuth, and so on of a well. What I would like to do is extract this data, probably visualize it in a 3D way, so I can see where the wells are located in the fields. As I mentioned, I didn't find any file with the deviation survey, but let's try to load it from scratch. So for this, I was using a PDF reader, and the library is called Tabula, and I'll show you what Tabula can do. And let me import first Tabula, and I'm going to also import my Pandas as PD. And so let's have a look. I would like to get and I put all the information in data. Div report, and I'm going to go into this in this particular folder. So just let me copy that path. So my file, it's located in this folder, and I need to add, I believe, the data route. So it's data, and this is 14 div reports and so on. Let me see if that is okay. That seems to be red. What I'm going to do now is store that table. Let's call it tables, and I'll show you why I call it tables. And I would like to extract the table. Let's extract this, for instance. So this is page 57 of the report. And what I'm going to do is using that Tabula library, I'm going to use from the functions the read PDF function. So I'm going to read the file, and I have to specify which pages I want to read. So to start, we're going to read page 57. Funny enough, this uses a string as an input. So I'm just going to set up that string, and I'm going to allow to read multiple tables. So if you see the information here, you can see that I can read multiple tables. By default, it's true. Actually, I don't need to put multiple tables because that's the default. Error, no such file. So in here. Oh, sorry. Let me put that this is row format. What's happening there? Just a second. Okay, let me try. Let me try with double slash. Oops. Data. Reports. Oh, I believe it's related to the spaces. There it is. That's fine. I'm going to read another location, which I know it's working. For the time being, let's use this location. Okay. So what is in that tables? So we have, actually, if you see those tables, those are comprised by number of lists in the file. So if we see, for instance, if I see table 0, so what is this? This is returning actually a data frame, which shows the first table here. So I can go from table 0, 1, and so on. So the table that I usually want from this set, it's the very last piece of a table. And so I can go to the table -1 and get the information from depth and so on of that report. So far so good. And the next thing that I'm going to do is I'm going to create what I want is to iterate on a couple of files. So I've got the 159F14 and the 59F15D, both with the end of well report. And I know exactly what's the name of the file and which pages I want to extract from. So first thing that I'm going to do is set up a bit of let's call it a well reports. I'm going to create a dictionary. And in that dictionary, I would like to specify, actually, let me create a list first. And in that list, I'm going to populate that list with dictionaries. So let me first create well reports.append, and I'm going to append the first dictionary, which is let's put here well name, and I'm going to start with the first well, which is the 159F15. And the other thing that I want to specify, it's what is the name of the file where I'm going to get the information from. And in this case, it's specified here at the top for that particular well. And the next thing that I'm going to do is I'm going to specify which pages I'm going to read from. So I have from the report, I want to read pages 58 up to 65, I think, or at least I think for the first one. This is a 14. That's in fact Here we go. This is what I wanted to read from, I believe. So report 15, D. Okay, 62 to 65. So I'm going to use a NumPy. So simply to import NumPy as NP. What I want to do here is specify the pages. I'm just going to specify a range with NumPy. So my range is from 62 to 65. So that's for the first file, and for the second one, I'm going to append another report. That will be the well 14, and the report it's located in this path. I want to read pages 74 and 75. Just a couple of pages, so instead of setting up a range, because if you see what this is producing, this is just producing a range 62, 63, 64, and 65, and this is just specifying both the pages that I want to read explicitly. So now I have a path, fine. So I can iterate through this list, and as I go through. So if I run this, let me show you. Well report should be called wells report. Well, let's keep it well reports. Well name should be, in case it's just a name. This is a name. It's a name. It's a name. It's a name. And now I have my dictionary that I can iterate through. So one thing that I would like to do is get the information from the well, and for that I'm going to use Welly. So let me import Welly straight away. And later on, I will also need Matplotlib, so I'm going to import also Matplotlib. And finally, I'm going to also get some functionalities to display everything in 3D. Okay. Import Welly, sorry, Welly should be lowercase. There we go. So that's loading. As you can see, my Python instance was still working. And so if let's do one well, just one well at a time. So I'm going to set the first thing that I need to do to get a well. It's use extract some of the data from the file. So I need to read some of these tables. So let's say for what I would like to do, it's for every page, the pages that I have in every well, and let's do this. For every page in the pages, first I'm going to create a data frame where I can start to put all these tables together. So it's going to be 1, 2, 3, 4, 5 tables, and I need to concatenate those tables one on top of the other. So I'm going to concatenate those tables and stack them all together in a data frame. And also, the first thing I'm going to read the file. The file, and let's use to start with. I'm going to use the well reports, and I'm going to use the file 0, and I want to get from that just the file name, right? And once I get the file name, through every one of those pages, actually, let me put this outside. For every page, I want to read the table. So I'm going to read, use the tables here. And remember that in this case, the pages are the pages defined here, which is, I can use pages in my for loop. And I want to, every page is just a number, and we have to put here a string. So we have to cast that number to a string like this. So now I'm pretty much reading for the first file, just for the first file, then we will soon iterate through all the files in the list. For the first file, I'm going to read every table, and I'm going to extract. So let's say the last table, I'm going to store it here. So every time I go through the loop, I'm going to extract the last table. And the other thing that I'm going to do is as I go through the process, what I would like is to make sure that I can take the previous table and put it together with the next one. So for that process, I'm going to use I'm going to store everything into this data frame that I define here outside. And I'm going to do the Pandas option to concatenate tables. So remember the concat option in Pandas, it's you can concatenate tables, stack one on top of the other, or stack in terms of columns as well. So you can stack on the row direction or the column direction. In this case, what we want to stack is the content of this table on top of the content of this table, and so up to the point that I have it, the whole trajectory. So I'm going to concatenate the original data frame and in the last table. So these two needs to be within a square bracket to concatenate both. And I'm going to make sure that I'm going to stack it on the axis of the row axis. Okay. I need to do something else, and before I do that, let me show you what's happening here. So at the moment, this is reading, and it's going to export a data frame. And you will notice that the data frame is not exactly as we would like it to be. So what's happening here? It's I'm reading the table, but it seems that it's offsetting the data of the table, as you can see. So in order to fix this, and the first thing that I need to do is make sure that the index is not actually taking into account. So I want to ignore the index, and this is true. And this is still not going to work, I think. Let me see. Okay, it's still not going to work because there is something else that we need to do with that table. And one thing that is happening is that you will realize that this has a comma separators instead of points. And we also have, if you see, as this is a comma separator, all these values are pretty much strings. So in fact, if I do an info on the file, you will realize that these are objects. These are not float values. And the other thing that it's happening is that the first column, it's processed as it's being processed as a column name. Okay, so we need to sort out that. So in order to sort out that, I don't know if you know about there is a well mapping, or sorry, a mapping functionality in Pandas, where I can apply a function with a lot of steps for every value in the Pandas data frame. So it would be an equivalent in Excel as generating a function and apply a function to every cell in Excel or a particular columns, which is not so straightforward actually in Excel. But in order to do that, actually, let me do something that I like to do here at the beginning, which is I'm going to define my these are my functions. So I'm going to define some functions here, and the function that I want to define, I'm going to call it a casting function. Casting, it's because I want to convert, when I want to convert an object from one format into a different format, in this case, from an object or a string into a float, that process is called casting. So my casting function, the first thing that I want to do is take whatever I have in there, and if you see one problem that we have, I don't know if it's noticed in any of these. I don't know if it's noticed there. But one problem that we have, it's these comma values. So the first thing that I'm going to do with the casting function, where is the casting function, is it's pretty much state that if I receive a value x here in this function, so that x is going to be equal to the same value, but I would like to replace those commas by points. Okay. I have this function. I haven't done anything with that function, but what I would like to do here at the end, it's once I read the whole file, I'm going to use one function in the data frame that it's called apply map or map apply. I don't remember, apply map, I think it's called. So apply map, I can call that casting function. Come on, what's happening? I can call that casting function, and for every value in here, oops, for every value in here, we will have replace the commas by points. So there is an issue with that, and the issue is that of course, if you see some of these values, we may not want to change the coordinates. We may not want to replace these values in the coordinates, but let's run that. Let's see what's happened there. Oh, and I think one thing that I haven't done here. So okay, float object has no attribute replace. So some of these values are floats, And I need to do actually this in order to store it. The f apply. So there are some floats which I don't want to convert. So one thing that I can do in the function, it's specify that if I have a float, I don't want to do anything with that. So if I can use is instance to check whether my x is a float, and then specify that when I have a float, I just want to pass. I don't want to do anything. And the other thing that this has to do that I haven't done here, and let me add here an elif. It's return something from the function. Actually, else. I want to return x in this case. So I want to return, if I make the casting, I want to return that value. So let's see if that works now. And let's see if actually the results make sense. So it's a bit of an iterative process. Yeah, as you can see now, I have converted some of those values to points. Still very odd, and still everything it's objects. But that's fine. That's fine. Let's carry on and do some more stuff here. And there are quite a few things that I'm going to do here. And I'm just going to show you, I'm just going to cut through the end of a casting of what I'm going to do with the casting function. But just to illustrate what I've done here with the casting function, I'm just replacing when I have quotes. Just a second, I think I have a question or something. Is there any question? Okay. Can you see my screen?
Yep.
Okay.
Yes.
Yeah, someone is saying that they can not see the screen. So what I have done is quite a few things. If I have a quote, I will return the value. I would, or actually I can pass. If I have a single or double quote, if I have 2 points, I will return not a number, and so on. And also, if I have done some other stuff, first I convert the spaces. I took out all the spaces and remove the spaces, because sometimes if you have 1,000, for some reason, this was detected as a space here, and as you can see here, between the 4 and the 0, so I have to replace that as well, and replace some of the dots, remove some of the dots as well, and also replace the commas by points. So if I run that and run this, let's see what's going on there. Okay, looking much better. And there is something going on these columns. I'll try to sort it as we progress. But this header, it's causing a bit of an issue. I don't know what. I don't see how I sorted that out. But let me carry on. And the other thing that we want to do is drop. If I have not a value, if I don't have values, I want to drop those as well. Okay. So that's pretty much it. Let's see if I'm forgetting something else. So that's pretty much it from the point of view of loading the data. And for some reason, let me see if I go to the second well. To the second well, what happens here? Oh, these pages are not correct. Okay. Right. Okay. So now I want to iterate through every well and pretty much return a data frame for every particular well. So the way I can do, I could do, it's I'm just gonna put this into a big loop. So this is another loop where I'm going to go for well in well reports. So now I want to iterate for every well in well reports. So I don't need this. I can go and iterate on every well. Get the file name for each well in the file. So even if I have, let's say, 20 wells, 30 wells and I have reports from a bunch of wells, I can pretty much put everything into the dictionary where exactly I want to read from, and then loop through the dictionary. That's more or less the purpose of this. Let's see what's happening here. So up to this point, I'm not doing anything with the data, and but what I want to do is first of all get the deviation survey. Get a deviation survey for every well, and this is where we have to use. This is where we have to use welly. Yes. So in order to use welly, we can do something like. Let me define here. I can do. In fact, let me put a. So this is deviation. So in order to do welly, I can do a set equal. Let's say this is a set is or W is a well. My well it's equal to welly, and just to see what I can do from welly. Okay, there are quite a few functions there that I can access. I'm going to access the well, and what I would like to do is from this well, I want to specify the location, and I want to add. Let's see if that w dot hold on a second. My Python instance is locked into a process. Okay, there you go. For some reason, it's not recognizing well. Okay, let me see. W.location, and I'm going to add the trajectory. In this case, I can use add the deviation, and I need to add 3 columns for the deviation. So if you go to the manual, and for some reason welly is not behaving, if I go to welly dot well, yeah, for some reason it's not bringing up the information. So I need to bring up the deviation, and the deviation that I could bring is measure depth, inclination, and azimuth. So I can bring this to the first 3 columns, but I need a NumPy array for that. So this deviation, it's pretty much the first 3 columns of the data frame, and I need just the location 0, and I would need also the columns 0, 1, and 2. So basically, I'm specifying that I want the first columns. In fact, I need the first 3 columns, and I need all the rows for those. Okay, so that is my deviation, and I need to convert this to a NumPy array. To convert this to a NumPy array. So now this deviation, now using Welly, I can define the well, I can add the deviation survey, and since I'm iterating on every well, I should be able to get that deviation survey for every well. The other thing that I can do, it's plot that deviation survey. So one thing that I can do, it's using the deviation survey. Just a second. Let me show you here. Just a second. There are quite a few tutorials here on the Welly website, and one that if you have a look at some of those, there are different ways in which you can see the deviation survey. This is a good one, and this is one thing that you can use is the location and the plot 3D. Let me use this one in particular. So I can use W, and again location, and the plot 3D. Okay, and I think I'm having a small issue here with my data frame. That my data frame should be ordered in a different way. I'm not quite sure what's going on with the data frame. So I'm going to let me see. Yeah, for some reason my headers are messing up the data frame. Not quite sure what's happening, but let me show you here on here the results. Okay, so the idea was to iterate through the tables and get a common data frame with every one of these tables. So at the end, what I was doing with those 2 files, because I was iterating through these 2 files, I was able to get the deviation survey into into a format that Welly was able to help me to plot the deviation survey. And not only that, I can use the datum and also the X and Y location of the wells. So you can see the XY reference here. And I could actually plot the whole trajectory of a well for those couple of wells. There is something going on in the exercise that I think there is a step that I missed, but you get the idea. So once what I was iterating through this, I could not only get the deviation, but I could also get the datum information. So this column 673 that you see here, this datum information, it's column 0, 1, 2, 3, 4, 5, 6, 7. So I could get the first point in the table as a reference point for the first value of a well, and then arrange that coordinate accordingly. The rest is pretty much the same. So I look through the well, then I look through the pages, and then I concatenated the pages and created the well. The only difference on this function is I separated the deviation plot in a separate function here, where I was doing all the deviation, arranging all the deviation. Okay. And ultimately, I was creating the figure for each well using a for loop. So I'm conscious of the time, just almost getting close to 6 p.m. So that's about it on the terms of PDF. The other exercise that I probably will have to leave for the next session, it's on the pressure information and how we can get the pressure information from the different reports, from the MWD reports. And there are tools for that you can extract all this information. I just found that it's quite interesting to have a look at the report. This is a Baker report where they have the MWD pinching the formation. They have the chamber they have a pump with a chamber, and basically they extract on different stages a certain amount of fluid, where you can measure the stabilization pressure and so on. So basically have all this information, all these plots in a last format. From this, you can get the stabilization pressure. So for the next session, I think I can start with that, showing how to get this information, how to get the information for the multiple stages or multiple wells, and if possible, almost identify from these where are those stabilization pressures, so which will constitute ultimately your equivalent to the RFT point, where you have the reservoir pressure measure, in this case while drilling. So I think we'll have to do that the next time. For the next time, I also have some information with the production data. So we'll have a look at how to extract the production data from the file, and perhaps we'll have to do a third session with the simulation model. So we have enough for probably 2 or 3 more sessions. If you have a look at the data and you have any particular suggestion, please by all means come forward, and we can work together, or you can do it yourself and then present to the rest of the group. And the other thing, it's I would like to remind some of you that we are developing the reservoir engineering, the material balance model. So have a look at the contribution guidelines in Orca Hub. So Orca Hub is where we are sharing all this material. And if you want to contribute developing multi-tank or implementing different aquifer zones and so on, and please, by all means, we need some help, or even documenting the whole application. At the moment, I have released a third version where it's a bit more faster, and you can run quicker quite few scenarios at the same time. So you can almost a sec on every scenario. So that's it from my side. So any questions so far? Any suggestions? Anything or anyone would like to come forward and probably offer a session for the next time? And thank you, Ankit, for also volunteering. And it was really good to know more about Volve.
Thank you.
Hello.
Yes, Felix.
Hi, Alejandro. I have a question for Ankit.
Yes.
Hi, Ankit. Well, about the Volve dataset. So I joined a little later for the meeting, and I couldn't see how you treated the null values of the world that you were presenting. So I would like to know that if I am going to treat the nulls, would you use data from the neighboring worlds to fill them?
So the thing is, we are working with a subset of the log. That is, we are working specifically for the Huygens formation, and in that case, if you've got any data points in between that are null, we try to interpolate between those data points, and the Valley library automatically does that interpolation.
Okay. So you use the interpolation method of Pandas to do that?
Yes, I mean the Valley library has got interpolation built inside it. So I really do not have to put in effort to calculate those values.
Okay, so I was wondering that if I want to interpolate, if I don't have enough data to do that,
yes,
I can fill them with the neighboring worlds. But I understand that I have to consider the depth and the nearest of the worlds. But one thing that I think that it's important to take into account is that depth of the data of the world. It's important to do that because I can feel the nulls with data from different depths. So if you have some examples of the interpolation of the field or the feeling of the nulls, I will be grateful to know that. And thanks for the presentation to Ankit and Alejandro. It was very insightful.
Yes, I'll share the algorithm with you that is used for the